Hi, my name is David Greider, and I'd like to welcome you to this presentation on the Wolfspeed Cree-Durham project with Power America on the development of a manufacturable 10 kilovolt silicon carbide MOSFET on 150 millimeter silicon carbide wafers, along with JEDEC qualification of these 10 kV silicon carbide MOSFETs. I am working with Dr. Edward Van Brunt on this project. In this presentation, we'll be first talking about the BP4 project, fabrication and JEDEC qualification of 3.3 kV 50 milliohm silicon carbide MOSFETs on 150 millimeter silicon carbide wafers. To the right, you see a die photo of the 3.3 kV 50 milliohm silicon carbide MOSFET, which has a die size of 4.9 millimeters by 7.7 millimeters. These were all fabricated on 150 millimeter silicon carbide wafers. We carried out JEDEC qualification on these 3.3 kV silicon carbide MOSFETs. This included HTRB, or high temperature reverse bias, high temperature gate bias, thermal shock, body diode operating lifetime, electrostatic discharge, and time-dependent dielectric breakdown. In addition, we'll be making a presentation on the BP5 project, fabrication and JEDEC qualification of 10 kilovolt, 220 milliohm silicon carbide MOSFETs on 150 millimeter silicon carbide wafers. To the right, you see the larger design of the 10 kilovolt, 220 milliohm silicon carbide MOSFET used in this the project. These were all fabricated on 150 millimeter silicon carbide wafers. We are carrying out JEDEC qualification of these 10 kilovolt silicon carbide MOSFETs, including high temperature reverse bias, high temperature gate bias, thermal shock, body diode operating lifetime, electrostatic discharge, and time-dependent dielectric breakdown. In terms of fit to mission, in order to enhance the 3.3 and 10 kV silicon carbide MOSFET performance, reliability, and yield, we will be utilizing fabrication on 150 millimeter silicon carbide wafers at the Cree, Wolfspeed, Durham fabrication facilities. In addition, there's a cost reduction of 3.3 and 10 kV silicon carbide MOSFETs because of increased number of die, improved die yield, and increased production volume on the 150 millimeter silicon carbide wafer fab at the Wolfspeed Cree Durham facility. To the right here, you see wafer maps of the Gen 3 3.3 kV 50 milliohm silicon carbide MOSFETs on the 100 millimeter silicon carbide wafer and the 150 millimeter silicon carbide wafer. On the 100 millimeter wafer, for these 3.3 kV 50 milliohm silicon carbide MOSFETs, there are 180 gross die printed per wafer. For the 150 millimeter wafer, there are 414 gross die printed per wafer. That corresponds to greater than a 2x increase in the number of gross die printed per wafer for these 3.3 kV 50 milliohm silicon carbide MOSFETs. A similar analysis shows that for the 10 kV 220 milliohm silicon carbide MOSFETs, there's more than a 2x increase in the number of these 10 kilovolt silicon carbide MOSFET die printed on the 150 millimeter wafer compared to the 100 millimeter wafer. We also need to establish JEDEC reliability of 3.3 and 10 kilovolt silicon carbide MOSFETs because they represent critical elements for the ultimate commercial release of 3.3 kilovolt silicon carbide MOSFET and 10 kilovolt silicon carbide MOSFET power products, including both device die and modules. And ultimately, we are utilizing these 3.3 kV and 10 kV silicon carbide MOSFETs to develop both 3.3 kV and 10 kV silicon carbide power modules at the Wolfspeed Fayetteville module manufacturing facility. In terms of a path to market, Wolfspeed is not only a top 3 supplier in silicon carbide power, but we are a world leader in 3.3 kV and 10 kV silicon carbide power development, including both power devices and medium voltage power modules. We're also working on greater than 10 kV silicon carbide power devices. Wolfspeed has been working very closely with major medium voltage motor drive and traction manufacturing companies, as well as major leading rail transport companies. We've also been working with grid distribution, control, data center, solar inverter, and wind turbine companies regarding the utilization of the Wolfspeed 3.3 kV to 10 kV silicon carbide MOSFET power device and power module technologies in all of their broad range of medium voltage silicon carbide applications. Cree will utilize established distribution channels for 3.3 to 10 kV silicon carbide MOSFET devices and modules. Initially, we'll be focusing on interfacing and selling directly to power electronics and module manufacturers. We are also rapidly developing internal 3.3 kV to 10 kV silicon carbide power module design and manufacturing capabilities at Wolfspeed, Fayetteville. In terms of BP4, there are two major groups of activities. The first is 3.3 kV silicon carbide MOSFET fabrication on 150 millimeter silicon carbide wafers, and then JDAC qualification of 3.3 kV 50 milliohm silicon carbide MOSFETs, including HTRB, HTGB, thermal shock, body diode, operating lifetime, TDB, and ESD. Thus far on BP4 project, we have completed 5 fabrication lots, including testing of 3.3 kV 50 milliohm silicon carbide MOSFETs on 150 millimeter wafers. The median breakdown voltage is 4.5 kilovolts, and the medium RDS on is 50 milliohms. Recently, we've had significant progress on JDAC qualification of these 3.3 kV 50 milliohm silicon carbide MOSFETs fabricated on 150 millimeter wafers. This has included successful JDAC qualification of high temperature reverse bias JDAC qualification, a successful high temperature gate bias JDAC qualification, and also TDB JDAC qualification testing. If you look in the upper right hand corner, you see the TDB plot for these 3.3 kV 50 milliohm silicon carbide MOSFETs extrapolated up to the operating gate voltage of 15 volts, which is the operating gate bias for these devices. And for these devices at that gate bias, you have a mean time to failure of greater than 5 million years, which indicates these are very stable gate oxides in these 3.3 kV silicon carbide MOSFETs. Down below, you see the in situ high temperature gate bias JDAC qualification testing results for these 3.3 kV 50 milliohm silicon carbide MOSFETs. We used three fabrication lots with 25 devices per lots for 1,000 hours of HTGB JDAC qualification testing, and that passed successfully. Not shown, but we completed successfully 3 qualification lots, 25 devices per lot of high temperature reverse bias qualification, JDAC qualification successfully completed for these 3.3 kV 50 milliohm silicon carbide MOSFETs. We also completed we're also working on body diode operating lifetime, thermal shock, and electrostatic discharge JDAC qualification testing for these 3.3 kV 50 milliohm silicon carbide MOSFETs. Again, this is all done on the 150 millimeter wafer fabrication. For the BP5 task, there are two major groups of tasks. One is fabrication of 10 kilovolt, 220 milliohm silicon carbide MOSFETs on 150 millimeter wafers, and then JDAC qualification of these 10 kilovolt, 220 milliohm silicon carbide MOSFETs, including high HTRB, HTGB, thermal shock, BDOL, TDDB, and ESD. We have completed the redesign of the 10 kilovolt, 220 milliohm silicon carbide MOSFET, which is shown here on the right. It's an 8 by 10 millimeter device with a lower on resistance than our previous 10 kilovolt silicon carbide MOSFET and a higher current. It also has lower internal gate resistance for reduced switching losses and an internal gate sensor for real-time improved short circuit protection. Recently, we have 5 of these 10 kilovolt, 220 milliohm silicon carbide MOSFET fabrication lots underway on 150 millimeter wafers. 2 of the fabrication lots have been completed and characterization is underway, including, if you look to the right, there's some data for showing 10 kV leakage currents, which is low leakage currents, less than 10 microamps for 10 kV for these 10 kilovolt silicon carbide MOSFETs from this fab lot number 1. In addition to these 2 completed fab lots which are being characterized, we have 3 more 10 kV, 220 milliohm, 150 millimeter silicon carbide fabrication lots that are currently underway. Summing up, on BP4, the 3.3 kV, 50 milliohm silicon carbide MOSFET JDAC qualification on 150 millimeter silicon carbide wafers We've completed 5 fabrication lots and characterized the devices. The median breakdown voltage for these devices was 4.5 kV. Medium on resistance is 50 milliohms. And to the right here, you can see the distribution of the breakdown voltage for these 3.3 kV silicon carbide MOSFETs. In addition, we've made significant progress on JEDEC qualification, including successfully qualifying high temperature reverse bias JEDEC qualification, successful high temperature gate bias JEDEC qualification, and TDB JEDEC qualification completion. And we're working on body diode operating lifetime, thermal shock, and ES electrostatic discharge JEDEC qualification, which need to be completed. On the budget period 5, we are working on, which is the 10 kilovolt, 220 milliohm silicon carbide MOSFET JEDEC qualification. This is all on the 150 millimeter wafers. We've completed the new design of the 210 kV, 220 milliohm silicon carbide MOSFET shown here to the right. It has lower on resistance and higher current rating, reduced switching losses, and improved short circuit protection. We've completed 2 fabrication lots of 10 kV, 220 milliohm silicon carbide MOSFETs and on 150 millimeter wafers, and these are currently under test. And there are 5 more 150 millimeter fabrication lots of these 10 kilovolt, 220 milliohm silicon carbide MOSFETs that are currently underway. In summary, I'm just showing the BP4 3.3 kV silicon carbide MOSFET on 150 millimeter wafers, including JEDEC qualification, and the BP5 10 kV on silicon carbide MOSFET on 150 millimeter wafers, including JEDEC qualification. Thank you very much for your attention to this presentation.